I think this is getting recorded. Okay, so microservices. The topic today we are going to discuss is microservices. So before that, I would like to take one discussion like if you have to build something like an online system, like a retail online, what would be the features you would be looking for? It could be like a Amazon.com, a very small scale. Like so we are putting a new company where we want to sell something, and right now we have very few users. So what could be the things we would be looking for if you're putting a online retail store or e-commerce store?
There should be something
Shopping
which
cart.
can help to explore the catalog.
Okay, catalog. And what I'm writing, you could able to see, right?
Yes, yes.
Yep.
Okay, what else?
Authentication.
Shopping cart.
Cart, good.
Payment.
Payment, nice.
Order management system. Yeah, basically including
Order.
Invoice generation.
Authentication.
Auth.
User management.
Users. What else?
session management. I don't know if that's technical or not, but yeah, we can leave. Yeah, users and session can be similar, right? Yeah.
What else?
Tracking the stock.
Stock.
Yeah, I mean
Inventory.
Inventory.
Inventory, shipping. Yeah.
Order status.
Inventory management.
And then and one more thing what was in my mind was search.
Oh yes, search is key.
Okay, so we are not designing the full-fledged thing, but just going to see like what could be the requirements high level. So I generally start with like something like a high level functional requirements, and there could be non-functional requirements. For now, like I have mentioned, like very small users, like 100 users are going to use it. So this is like pretty much small system which we are going to design right now. So at high level what I need. So if I have to tell like what could be my high level architecture, there would be like a client. Then I can put like a backend service. And what should be there here?
Database.
Yeah, database. So basically I can just say like, okay, this is my client going to interact with my service. This service would have all kind of things like orders, catalog. It would handle everything. It would handle payments, everything. What we have discussed, this service is going to handle, and it is going to talk with the database. Database right now schema, we are not going into that. That could be anything from different ranges of databases, but right now some database. And as soon as we'll start peeling the layers, we'll see which could be the best technology we could use there.
What about like third-party service like payment or shipping?
Yes, right now we are not going into that much detail. Right now this service is doing everything. Any external system it has to call, this guy is doing that. But client is going to interact with this guy. Any other processing, calling, third party, the responsibility of this service. Can somebody tell me what kind of architecture or this service looks like?
Monolithic.
Right. So basically, we are talking about one service which is doing all my things, and this is the monolithic thing. So basically, this service is doing all my work. And what problems you see here right now?
So if we fix something in a small part, so we will have to deploy the whole application. So it will impact all the components.
Right. So what kind of things in modern day architecture or modern day development is going through? You might have heard about this CI/CD.
Yep.
Continuous integration, continuous deployment, DevOps thing, right?
Yep.
So modern day world, development is not like we would be developing for 3 months and then we would be waiting to deploy. It would be like as soon as you're ready, you will deploy it. There are companies which deploys every day also. So things has been changed. Like as soon the feature is ready, it should be shipped. Other things which we are looking for is agility. Then testability. Then we are looking for deployability. And then what else? We are looking for scalability. And then we are looking for availability. This is high level things which are in my mind, like when I'm thinking about modern day practices, development situations and application situation. Anything else in your mind which you think could be needed?
Maintainability.
Maintainability.
Similar, yeah. But
Let me put there. So with the monolithic thing, can I do a couple of things? Yes, I can do scalability. If there's more load coming, I can vertical scale or horizontal scale. Anybody anybody's not aware about horizontal scale or vertical scale?
Hey, hi, Aseem. Can you explain what is agility mean?
Agility is like in this. So for me, agility is in this agile world. How you do your scrums. You always are flexible to deploy new things, make new features, and you always be agile in terms of development. That is my understanding.
Yeah, so we can take like that. So like if there are, we are working on two features in that. One is that there is something enhancing the order part, and there is a payment gateway. We are changing that. If somehow payment gateway is ready, but still we will have to wait to deploy it until the order part is complete. But now if we split that in a separate component, so if payment part is ready, so we can just deploy that part and we don't need to have a dependency on the order part.
Yes, that is one way. Then testability is how easily you can test your things. And then deployability, how easy you can deploy things. And with scalability, and how you scale your application. Availability is like, is it your application available all the time? If this guy is down, then the entire application is down, right?
Yes.
And maintainability, how you maintain things. If somebody new person coming in your team and he has to start with the entire service, so it could be difficult to go through everything. And let's say if a lot of teams working on one code base, then they can have a lot of conflicts in terms of their merge requests and other things. Like another thought is just coming to my mind just now. So yeah, so these are the things which I was thinking about when I thought like, what modern day requirements needs looks like.
Asim, one thing we can add, yeah, that is modularity. It's like we can divide our application based on the functionality. Like tracking application can be separated from the login application. So we have two different modules which are not interrelated. So
Yes.
modularity we can also add in these points.
So that's what that's a good point. That's what I want audience to drive into now. Like how can this be, how these principles I can apply on this? If I have one service, can I break down into different things and then I can achieve these kind of things?
Yes, we can.
So if I think in terms of microservices or modularize it, so in that way, I can have different layers here, which is doing different things. And then my application is talking to that different layers. And then right now, let's say they are all talking to the same database. So this could be module 1, module 2, module 3, or it could be like a microservice 1, 2, 3. Now, if I split this thing, can I achieve all these things now or not? I can be agile in terms of what I want to develop or deploy. Testing is easy as I'm going through the small phases. Deployment is easy when if only one feature I want to deploy, I don't have to deploy an entire thing. Scalability is easy. I can scale one service based on the need. Availability maintained. So these all things I can play around if I start splitting the things into small modules. Now the question is, why suddenly in last few years everybody started talking about microservices? Why this could not have been done before? Anybody wants to take a shot?
Yeah, so one aspect is we are seeing there's a lot of explosion in the data. We are seeing a lot of data, there's a lot of computation involved, and people are moving to the cloud as well, right? So if we are into this monolithic approach, things will take more time. The time to get into the market is slow. So in order to solve all of this, it's better people started to think how if I solve one problem in independence of with others. And that's how I feel that microservices kind of took birth, and people were using it in their companies, but they did not label it as microservices. So that's how I think it should be the right approach.
So yeah, so I have also thought on similar lines. Let me quote example. Few years ago, like I think in 2015 or 16. So generally, I was having a monolithic service, was having on one application server in a data center, no cloud. And then if I want to add more load or more services, that time, what used to happen, like I have to acquire new hardware. I have to first raise a request. Hey, in my topology, I want to add a new box. It has to go through a lot of requirement, a lot of approvals thing, got approved, new hardware will come, we'll put that in the data center, and then only we'll start putting new things. This was one scenario used to happen few years ago. But now in the modern cloud world, this architecture and landscape has totally changed. Doing a deployment and other things becomes so easy right now. So think in that way, if I have one service, I divide into 10 services. So that means I have to handle a lot of things. I have to deploy 10 different services. I should have that much infrastructure to deploy on different. So anything has to be hosted somewhere at the end of the day. So it has to go somewhere, and I should have enough infrastructure, resources to support that. With this cloud world, for me, this becomes so easy. And with new technologies like containerization, this becomes so easy. Every service could be in one single small container. It does not need to be in it doesn't need to be in one full-fledged box, what I'm saying. A small container could work. So, and feel free to stop me if you're not aware about container and other things. So that was my take on that.
But there would be a lot of communications, among all the services, right? Because before we have only one service, now we have multiple microservices.
Yes. So,
well, and I thought that the difference between microservice and like the old SOA, the service-oriented architecture monolith, was deployment capabilities. Is what it came down to. Like you could deploy each microservice independently, and then when you add things like async or asynchronous messaging and stuff like that, then that helped increase the reactivity of the system.
Sure, that is a good point. So, but let's go one step at a time. So right now we were there at monolithic architecture. Everything was together. They used to call each other using function calls. But now we have split the things. And while splitting the things, right now, what happened? Still, I have small users. Like I have only one instance of microservice 1. I have one instance of microservice 2, and I have one instance of microservice 3, and this is my database. And they all talk to one single database and internally, they communicate to each other using some pattern. It could be like how the services can communicate. One, it could be like remote procedure calls, REST based, or they send messages to each other. So these are the things which they can talk to each other. That's on my mind. So that that will increase the communication thing. But if you see over the few years, the communication also improved a lot. Calling each other, network, bandwidth, messaging. So these all things become super cheap. So that's why we don't care like if how many components talk to each other in this cloud world. So Leon, that answered your question?
Yes.
Okay.
But to me, it feels like it's still a lot more, management to keep track of our services. Before we have, only one, either we deployed it or not deployed it. But now we have many of them, and keep track of the. If one of them fail, then
okay. So yes, let's go into that part. So right now, I was only having 100 users, few services, and easy.
Sorry to interrupt you. So you were talking about containerization, right? Can you give more detail about that?
Yes, we'll go into that. Give me some time. We'll come to that when we'll start scaling things. Right now, I was having only 100 users, few requests, and we'll add more load. That time we'll come to that.
Sure.
Because I was thinking to go one step. We'll start putting more things. So right now, things are working fine for me. I have split these things. I have put that on a, like say, I put on a EC2 instance. All services are on a EC2 instance. And directly I'm exposing my EC2 IP to my client. And that's how, or using this Route 63. So using that, things are working fine for me. Few users, everything on a separate EC2, and now that's how I have started. So coming back to Leon question, like how we'll maintain it? Yes. So right now my system is small. I know what all components are there. There could be, if something is down, somebody manually looking into that, because I have not invested that much to like auto monitor. So that's how I'm doing right now. But let's say I have increased a lot of my functionality, and now I'm adding a lot of different services. So this will keep on growing. The components of my side will keep on growing. And then I have to think about a better deployment or better hosting thing. Where, what things should I do now? For example, let's say I have a load, I have a component here which will take orders, and this is on a EC2. And let's say I put a sale. On Thanksgiving or New Year, I put a sale. So now a lot of users want to come to my site and place order. So this means the traffic for this guy will increase now. So what should I do now?
Vertically scale that system.
Yeah, so I can do vertical scaling, increasing the computation of that system. If it is having 16 gig of memory, make it 32 gig or 128 gig. If it is 4-core CPU, I can make like 16 or 32. So one could be this thing like a vertical scale where I just add more computation on the server. What else I can do?
Add in more services?
Yes, I create one more instance of order service. But you remember this was on a EC2. How long EC2 is like a virtual box. How long a virtual box takes to spin? It could be, I have seen on average could be 1 or 2 minutes or 3 minutes based on what we are looking for.
Yeah.
So So there is a 3 minutes time where this guy will be alone handling things and this guy is spinning up. So that means for that 3 minutes, anything can go. My service could come down till more instances are coming in. And if more instances are coming in, I need some way to route the traffic to all the instances. So new things will start coming into picture. But first, let's discuss like this 3 minutes time, how I can fix this.
We can take a snapshot of the current virtual box.
Mm-hmm.
And then when we need it, it's gonna start up maybe faster because it already have the state and the information in there.
You mean like with the service code, everything?
I'm thinking, yeah, maybe they have a software installed and everything, the database, and everything now. It's like we save the state of the virtual box.
Mm-hmm.
So now we just run, bring up that state that faster than started from the beginning.
What we can do here, we can predict it, and so like if my load is 60%, so spin a new box ahead of time.
Okay, so what if my load comes down? Shall I kill that?
Yes.
And then again, after 5 minutes, load came back. Shall I again spin that? In the 3 minutes window it took to create and 3 minutes window took to kill, and that time I'm just trying to predict it.
So we can have messaging queues or bus, like to queue in traffic.
So what is the problem?
This is where containerization comes in, right? Like you.
Oh yeah. So I was thinking somebody will say container. So basically the underlying problem is hosting, spinning up a EC2 and putting things, deploying things, and that was taking time. That's like was my take on this. So if I improve something, and if you remember, this is a very small component, order service. It is a microservice. It should not need a full-fledged EC2 to run. It needs things which it's supposed to, and then it's done. So if I just put that in a container, and spinning up a container is pretty fast. It takes few seconds, or even in few seconds, a new container can spin up. And when I have to scale, in few seconds, I can add more containers. And if the load is coming down, I can remove the containers. But still, remember this, I'm still doing manually. Myself looking in the load and adding more containers, but still, I was able to fix that purpose where quickly I can add more instances and remove instances.
One thing I know about Lambda functions is like those are good for these kinds of situations only. Like when there is a spike, Lambda functions automatically like handle those spikes, and like when there is less spike, they will settle down. So
Lambda function is very particular to one functionality, but service could have other functionalities also.
Are you talking about serverless? I don't know.
Yes, serverless.
But here he is talking about servers, right? Like the service which is running on a particular container which has a web server.
So when we have to spin the container, so that will spin. We will require some sort of a host for that, right?
Yes.
So the host should be ready for that.
Yes.
Only in that case we will get the benefit to use that container.
Yes.
If we have to spin the host itself, we will be in the same situation, right?
Yes. So you already gave me a solution for that. So now
can we think of Fargate approach over here?
Yes. So now coming to modern day development, like I mentioned in the start, how these things become so simple these days. If I have to do in few years ago, this was something I have to do myself. Like I have to maintain underlying infrastructure. If I have to add more containers, the underlying infrastructure should be ready. At the end of the day, container has to be hosted somewhere. It should have. It is going to take somebody's computation or it has to come. The computation and memory has to come from somewhere, right? So these days, the solutions like Kubernetes, Fargate, and ECS, Elastic Container Service. These things made things so simple, where they will manage everything for you and you pay for the things which you are doing. So if I'm adding more containers, so let's take about this Fargate, where it bills you for the containers you are putting. So basically, and this is a AWS service, and Kubernetes is a Google one, and ECS is also AWS, and even for Azure, they have, I forget its name. Azure also have something similar. I think they also have something similar for Kubernetes. So basically, these kind of things where I can quickly add more containers when it needs, and then remove when I don't need them, and I only pay for things which I'm using. So basically, Cloud World, how it works, it's like your electricity bill. How much you use, you will get the bill. If you are not using, you won't get the bill. But for EC2, if I have spin a EC2, I would be paying for that EC2 whether I'm using it or not using it. Was that okay? So
yeah, that makes sense. Yeah.
Sense, or it is like too high level things or conceptual things I'm telling? Just feel free to stop me. I'm just giving you pointers which you could use in a system design interview, like things you can talk about, hosting and other things which could be helpful, and things you can read yourself so you can talk about them in the interview.
So a container is basically something which helps in, I mean, just reducing the time of instantiating the new instances.
Think container is like a virtual machine only. I'm not, so it is not a full-fledged system. You can make a full-fledged system out of container. That will become easy too. But let's say I have a very lightweight Linux box, very lightweight. And then I have a JRE there, and then I have only my service. This would be mostly like 400 MB. A virtual box machine EC2 could be like in GBs, but this would be really lightweight, like a 400 MB thing. Very basic Linux, JRE and a service. If I start adding a .NET framework over here, database, then it's as good as I've created a EC2.
Mm-hmm.
Does that make sense?
Yeah.
So it's very lightweight. You have ability to create your image, and as soon as you use that image to create new instances, that's it.
Does it take time to warm up the microservice, or it's fast to start from code?
Sorry, fast from start from code?
I mean, is it take time to warm up and make it ready?
Oh, you mean the cold start?
Yeah.
Yes, the cold, again, it depends, like I mentioned. More things you'll start putting over here, it will take more time to start, and it will have its own cold start time. So we have to make it really lightweight and only put things which are needed, and don't put things which are not needed. If you have to put them, then have a separate service or a container. That's what I was trying to say.
Okay.
To make it lightweight as much you can. If you can't, then see, again, in system design, there is no right and wrong. This is just situation. In our situation, we want to scale it really fast. So we are picking up a containerization technology. If it could be some other requirement, we could do, okay, let's do some other technology. So right now, where we are, we got some load. We are able to scale using containerization, putting it in some containerization technologies like Kubernetes, Fargate, where I don't worry about underlying infrastructure. I only worry about telling, hey, I need more container, and it will spin up for me. But right now, I'm keep on adding a lot of containers over here. So that means there are a lot of things will start coming in. How my client will know which one it has to hit, and how I'll make sure that one of the instances not getting hit like really crazy.
Load balance.
Like load balancing.
Yes, so I can introduce something like a load balancer here, where I can keep on, which will keep on track on which could be like a service discovery for me, which could track how many requests one instance is handling. It can also track like if one instance is going bad, it won't send requests to that. It will tell Kubernetes or someone, hey, this guy is bad, and will spin a new container there. So, and my client would hit this load balancer, and that will take care of hitting internally. Does that make sense? Anything anybody wants to add for load balancer? Any thoughts?
So for the load balancer, like each order and each microservices has a lot of containers, then the load balancer is going to manage all of those containers. I mean, where to direct it, or like, is there a central thing that he directs, and from there on, they will choose which container to go on?
No, I think load balancer will take care of it. Will every container will register a load balancer, and it will know like, okay, I want to. It will have its own logic where it will have its own logic where it will redirect to different containers. So I don't know if load balancer will redirect to some other component, and that will do. In my what I have seen so far, load balancer will do that part entirely.
What's the difference
But
between
like,
load balancer and API gateway?
Okay, we'll come to that. Give me a second. We'll come to that on the API gateway. Give me. But is the load balancer part is clear? Why I have added a load balancer?
Just a small question.
Mm-hmm.
Like in this case, the load balancer will become a single point of failure, right? Like in case the load balancer goes down,
Mm-hmm.
then the user will not be able to reach any of those services that the load balancer manages.
Yes. So this load balancer should be really reliable. And if you're using cloud technologies, they have their own way how they'll make sure the load balancer should not come down. They can replicate things. They can have a master slave kind of or failover kind of or master slave. There are different patterns they can use, but I want my load balancer to be reliable. If I have to do myself, then I have to take care of this thing. But like I mentioned, why these things are more happening these days, because we get these things handy as a service from cloud vendor.
Yeah, they usually have follow like master slave. Something happens, the slave will come up and take over the main master load balancer, whatever.
Yeah. So yeah, the more you invest, the better you will keep on getting things. That's sort of like how the cloud works.
So internally, let's say one microservice need to communicate with another microservice. Does it know, have to know the IP address, or where to go to communicate with the other service?
Yes, so every service could have their own load balancer. The other service would know where is the load balancer. Or if you think your IP or things can change, then we can talk about this API gateways or Route 63, which are consistent. And underlying, you just change the IP. The CNS name would remain constant, and underlying the things can change. So your service would only know like, okay, I have to hit this URL. If things underlying change, we have to update them. We can make some consistent things, constant things, which won't change. Does that answer this question?
Yeah.
Okay. So what I was trying to say, like load balancer will have its own IP, but we can have what they say, this Route 63 in AWS world, which will be mapping to that. Any questions over there? So another thing which I want to really quickly want to cover, but will not go really deep in that, is that so as soon as I add more instances, it would start hitting my DB. So I also want something kind of a check where my DB should scale, or my DB should not become single point of failure. Or can I do some kind of a rate limiting on my service side where I should start adding some kind of a limit where how many requests I would handle before it will not start taking more requests. So there are different things which we can do there. But again, it's a design decision based on your application requirements. Like, do I need to put rate limiting here, or should I keep on scaling? Should I scale my database or other components, which is talking, again, it's a design discussion. But yes, another thing we can introduce is a rate limiter.
I think one other common scenario is like if you split your microservices, there is also a tendency of splitting the databases towards like orders will have orders database, and catalog might have its own copy of database. Like, so probably whichever microservice like doing like the orders will own the orders database, something like that.
Okay, so that is a really good point. We'll give me some time. We'll come to that as soon as we start teaching the databases. So is this part clear till now? What we split into services, we introduced load balancer, and one other thing was this API gateway. Why I need an API gateway? I think somebody asked that question. And so there are technologies like Apigee, and what was the other one? Akamai. There are a lot of things which will provide this API gateway solution. But why I need an API gateway? Anybody wants to take a shot?
One is for rate limiting.
Okay, rate limiter. What else?
And to authentication and authorization purposes.
Okay, it can take auth also. What else?
To map the incoming request format to the internal request format.
Nice.
Monitoring.
Monitoring could be, okay. What
To register our multiple microservices.
Yes, so I think these are the valid points. So basically, if I have a lot of load balancers also, I don't want to expose all of them outside. It could act as a proxy for me, where client will only know the API gateway. API gateway will then redirect to different components. So my client would only know I have only one component xyz.com, and then internally what it is doing, my client does not know. That is like my understanding on this. If somebody has more detailed thing and want to share, please feel free to do that.
So Aseem, what is the external facing component in this case? Is it the API gateway or the load balancer, or can just one entity be both?
It depends. I don't want API gateway. I can expose all different components using Route 63. Or it could be like I only show, so see, load balancer won't come, API gateway will also not come free. It will have its own cost. So it all depends on me that what only one service wants to interact. So could be like, I have a lot of services, but only few services my client wants to talk, then I can even expose that to my client. Okay, these are the list of services you want to call.
Aseem, is it Route 53 or Route 63?
Oh, I think Route 53.
Oh, sorry. Yeah.
Sorry for that.
Okay.
I was getting confused.
Yeah. No.
I think that came from the route. There's a route in US 53. I think it was derived from there on the fun side.
For the API gateway, does the microservice know who the sender is, or the API gateway block who the sender is?
Yes, so that is a good question. It again depends on us whether I want some kind of auth here, want to block, or it could be like a Google search where we don't want anybody to block. So any traffic should flow in, or it could be something where I want to block or do some malicious block some malicious users. Again, it depends on how my application is and how I want it. For me, like I'm building this retail, I want anybody to browse my catalog. So I don't restrict on a user or an IP.
So to add on to that, right, most of these HTTP calls are like usually for microservices are stateless. So if it goes from one service to other service, you need not, the state need not be transmitted across the protocol. So maybe the person who asked this was more interested to know on this. So it's all stateless for microservices. That's the standard.
Yes. So you want to discuss more on in terms of stateless?
No, I think the person who asked was kind of curious on this side. So I pitched in and said maybe it's stateless.
Yes. So most of the things are stateless. So Leon, you want me to explore on stateless thing?
Right. I think my my thinking was like the API gateway like a proxy, it would act like a proxy. So the client only know the proxy, and the proxy only know the client, and then from there on go to microservice. Microservice doesn't know who the client is. It just fulfill the request and send the response to API gateway, and that API gateway will send the response to the client.
Yes, that is correct. So basically, we don't want to add that kind of logic for a microservice to detect who is my client. These all things should be handled either at load balancer level or API gateway level. Microservice, if I start adding more things, remember, like my container should be small. So it should only do what it's supposed to do. Other things, auth, filtering, limiting should be done outside, what I will say.
Okay.
Can you talk about statelessness that you mentioned?
Here you can say that for microservice, the client is your load balancer.
For microservice, my client is,
because load balancer is making a request to or transferring request to the microservice, so it will reply back to the load balancer only.
Yes. Yes, other way to look into that.
Can you explain what is stateless when you mentioned that?
Yes. So the concept of stateless is when you, so let's say client make one request to they're going to order, it process that request and send the results back. Now it does not hold like when I got the request, what things I've sent back to the client. Client has to store this. For example, instead of order, let's say client was doing a search. So client asked for give me all items related to beauty. So it will get all the beauty products and send it to the client. Then it does not, after that, it won't remember like what I have searched and what I have sent it back. If again client tell, oh, sorry, I forget what you have sent me, again, give me back. Then again, this guy will call database and query that and send it back. Or it could be like your request can go to some other instance after that. It won't know like last time what other instance have sent the details. So basically it will serve its purpose and forget about who has called him and what things he has sent. It won't track that.
Okay, thank
that
you.
was my understanding. If somebody has a better understanding or want to chime in, please feel free to do that.
Could you please talk more about that? In what scenario we should use REST, and in what scenario we should use RPC?
Okay, so I'm not the expert of RPC. I have always used REST, and REST is I think widely used standard right now because it does not depend on any technology or thing. It follows standards like what they called HTTP verbs. So I would only go with REST. I have always used REST. I have not used RPC. And that's what like, if somebody wants to chime in, please feel free to do that.
Yeah, maybe I can add little context, which I know. So we all know that like REST works on top of HTTP, right? And it has its own good set of practices or principles, like in the form of HTTP methods. So, but like RPC, as we know, like it directly works on network, right? Like it's just like a remote call. So if you see the recent trends on protocol buffers or gRPC, they directly work on, I mean, like using the RPC mechanism. So I think if you compare this REST versus the gRPC, I think like gRPC in terms of, I mean, like benefit comes if we use like gRPC typically works in the uses protocol buffers, which are efficient in transforming, right? I'm just explaining one of the mechanism which I know. So they work in protocol buffers actually efficiently convert our messages in the form of binary and transfer over the network efficiently. If there are some, if your load is so high and I mean, like what you transfer over the wire matters, like the binary is quicker and gRPC also has some streaming. So I think there are some little benefits if you look at large scale, like lot of data being transferred over the network. In those cases, I think maybe a protocols directly on RPC might perform better than this REST.
So
yeah, another thing is like Sachin here. Sorry to interrupt.
Oh no,
so
please.
Yeah, so something like in your example, like retail online, right? This is what we are trying to build. So when our system like cart is trying to call the payment service to get the data, like what are the valid payment instrument for me? So that time, what we will try to do is through RPC. We will not make a REST call over there. REST call mostly we prefer like when client is calling to this retail website, and we don't want to provide him how he will authenticate and everything. So either he will do a get method or a post and provide the, if he is already logged in, as part of his request, we will prepare the token and everything, and that will be part of the REST request, and it will reach to our system and we will authenticate there. But in the RPC, first we try to authenticate separately and then make this call in the RPC.
Question, can the RPC go through load balancer?
Through load balancer?
Yeah, because we were talking the microservice, we talk to another microservice through the load balancer.
It can, yes. It can definitely go through load balancer, but load balancer will not be something which we usually talk as load balancer in practical example. Like load balancer here, we were, when he was explaining earlier, was something which was trying to distribute the load among different hosts so that there will no crash happen, or if one host is in ideal state or is not working, some other host is assigned to it. But it can go through a load balancer of a small microservice when other microservice was trying to call it.
I thought like RPC, they need to know point to point, right? It have to know the others, you know, where it is. So how do we scale it? But have to know, you know.
Yeah, I also think so. I think RPC is mostly like a point-to-point connection, and it will always be activated all the time.
Is not my REST API calls go to the API gateway?
No, it will go, but right now we are discussing about difference between REST and RPC, remote procedure calls.
Okay, I have got something to add there.
Sure, please feel free to do that.
So very simply, remote procedure call is just like a function call. It is a procedure call to a remote machine. So think about any function calling another function. If it is inside our process, then we know because of the linking and all the stuff, we know the name of the function and we just call it. And in the process, the linker has already linked us and it basically calls the function. If we are going beyond our process boundary, if we are calling a process which is sitting in the same machine but in another process, then there must be some kind of a register mechanism where that function is exposed and we just call that. So that is it is a system level RPC. Now the RPC we are talking is actually beyond a system, beyond a computer. The computer is sitting somewhere else. Now there are two things coming to picture. One thing is discover which computer I am trying to talk to, and that should support the method that I am trying to call. So there are two ways it can happen. I mean, there are various ways. So one thing we discussed was discoverability, then the actual sending the data, and basically the other computer executes it, then it sends the result back to us, and that is how the RPC process is completed. Now, this transaction can happen in various levels. One is there was something called SON RPC. That was happening at the TCP transfer level. So that 7 stack we have, network seven layers of the network protocols. So in the transfer level, what is that? TCP transfer, right? Yeah. Transport. Yeah. So it was happening at the transport level. So for that, you will have to something like, obviously, discoverability is another challenge there. So they had another system for supporting the discoverability. So before the RPC call, you basically say, hey, which machine should I go to? What is the IP of that machine? And then basically there is something called port mapper or something, or RPC bind. And that basically gives you that information. Then you basically send your call to that machine. So there is something called packaging your data, that is called marshalling. Data goes over wire. That other thing basically unmarshals it, basically unpackages it, then executes the function for you, then packages the data back and it reaches you. So that was one thing. Now in the modern world, in the new world, we are saying why transport level? Let's go all the way to application level. In the application level, we can reuse the DNS for discoverability. It is already there. And then basically we have got the API gateways, which are basically there to see which API. So in a sense, every web browser is sending a GET request to start with. Get this particular, I want to get this particular, say facebook.com over HTTP 1.1. So that is how any web works, any web browser works. So if we want to just reuse that same mechanism, and we have got this function called XML HTTP request, XHR or AJAX, basically that is what it is called. So if we can make use of AJAX, then we won't have to even bother about this non-standard port mappers of the transport level or anything. So we can go all the way to the application level, make use of DNS for discoverability, and basically the browser can simply send a AJAX call, get some URL, say Facebook/API v1 get user, say whoever that person is, Mark Zuckerberg, and then basically, because we are using HTTP, we already made use of DNS. We reached the Facebook's computer, and there one system is basically listening to this type of API calls, and it executes that call. It knows exactly what the intent of the procedure, the call is, and it gets me the data back. So that is basically the new RPC we are talking. So the technology that the API, so REST is the, so the GET that I just now used is the verb that is called a REST verb. So that is the REST technology. How the data is marshaled and unmarshaled? Basically, one way is You can use JSON for communication. There was another thing, XML SOAP or something. Previously, they used to use that. So there are different versions of formatting, packaging and unpackaging the data. And we have almost come to a stage where everybody is using REST and JSON. That's my understanding.
Okay, great.
That was a fantastic explanation.
Really fantastic.
Yeah,
Like crystal clear about the topics. Yeah.
Yeah.
Really nice.
From my experience, if you've ever tried to use the things that REST replaced, like RMI or Corba or any of those kind of things, REST is a whole lot simpler. And like you mentioned, most of the mechanics like DNS are already there for you. But great job on that explanation.
Cool. So I would like to proceed further. Thank you for your time. I would definitely like to talk more about RPCs and REST.
Yeah. One more thing. It's RPC is like that have the synchronous call, right? So it request response, and if it's synchronous call, then how would it scale?
Can I take that?
Sure.
Okay. So anytime you go beyond your process level, it cannot be synchronous. I mean, it is upon you if you want to block yourself until the response comes. But think about it. Once a request leaves your machine, nothing is under your control. Only your machine is under your control. See, the request is going. Who knows? The undersea cable might be broken. It might not even reach the other computer. So how it is mostly people use asynchronous because of this nature, because first of all, you don't control the machine, that may not be existing. You don't know the latency. You don't know how long it is going to take. So it is always prudent. It is always more, what should I say? It is always better to not to block on the call. Because if you're blocking on the call, then all the other experiences that your application would have been able to provide, it is frozen. So the user will basically run away. You will lose customers. So what happens is, once you do the RPC, mostly you don't block on that. I mean, you can, but you don't, because you will lose customers.
Yeah. So can we also compare message? So message is what? Message queue?
Yeah. Yes. But right now, I want this to be a separate topic, messages, how the messages will work.
Okay.
Because that itself is a full-fledged topic. So probably today or next week, we can cover that.
Yeah.
Okay. Okay, where we were. So we were here where my API gateway is there, load balancer is there. It's my service is scaling. We are doing rate limiting, but again, in this system, can you point the point of failure?
Load balancer?
The gateway itself?
API gateway?
No. Yeah, that could be one, but
Okay, so we agreed that we are making it highly reliable.
yes.
Single database?
Yes. So right now, this is still a point of failure for me, single point of failure. If my database is going down, the entire system will collapse. And yes, there could be other point of failures. I don't want to, if somebody is chiming in, please feel free to complete it. Somebody was telling something. I think
I was thinking about load balancer if we are not using cloud technology.
Okay, so like, yes, that could be. Like, say we are using cloud technology here. Everywhere we are using cloud technology.
We already said load balancer will be a master slave architecture. Yeah. So it will be available. Yeah.
Yes, we will say like it is a reliable thing for now. Anything else? Right now, one candidate is this guy, which is this. One, we already talked about this, but we thought we already thought like this could be manageable. But right now, this is like bothering our system, where all the requests are going to one single database. So there could be different things we can do in microservices. Every service could have its own data store. And different things we can do. But the problem here is like, there are other problems which will come into picture, where your data will be now in different data stores. And like say, here it is updated, here it is not updated, that things we have to manage ourselves. But the good part is always start with one single database and then start splitting based on your need. Let's say this is my search service. So what should I do? Like if there's one single database, which is RDBMS, that would be really slow in terms of search. Search should be really fast. There are different technologies like Elasticsearch, which could handle it really quick. So why not I put all my search here, and search is talking to Elasticsearch and getting all my search results. So I'm just giving hints, where should I break and what kind of data stores should I bring in?
So let's say, first of all, we can start splitting our databases. Let's say where we need the relations, we can go with SQL databases, and where we want, we can go with NoSQL databases. Plus, with the search functionality, we can redirect or wrap up our APIs on the Solar or Elasticsearch. Plus, there are some front-end APIs, like they always they can be served from the cache, so we don't need database even that for. So this is we can segregate our APIs based on the data store. That's it.
Yes, that is actually a really good point, and thank you for bringing that cache thing. I forget that totally. Before fixing that single point of failure, can I think about caching, where I should not hit my database so hard and I can use cache? So there are, before splitting database, first thing could be like caching could be introduced before actually I start splitting my database. And yes, so actually I forget that. So thank you. So did you got my point? Before splitting my database, I can even have a caching layer, which will serve my frequent requests and other things.
Is it like an in-memory cache, or?
Again, caching could be a full-fledged different topic. It could be an in-memory cache. It could be centralized cache based on different technologies available. It could be Redis, which could be centralized in one place. All systems could be hitting that. It could be like a Rabbit, no, not Rabbit, sorry, Memcache or something. So it depends. I want a centralized cache, or I want a distributed cache, or I want in-memory cache.
Okay.
I want to give one use case of my project. Yeah. So let's say we have multiple APIs, and uh, we have a mobile application. So let's say for the home screen, the data is not a user specific data for each and every user. So that is like a generic data, which is same for everyone. So we have put it that API as a in a separate microservice, and that microservice only talks to cache, that do not talk to database.
Okay.
And we serve that API only from the cache.
Okay. So yes, again, different scenarios we can bring in. Again, it depends on what kind of system design you are doing in the interview. And you can bring, so different components. Okay, I can bring cache here. I can't bring cache here. Different things we can do. But here we are just talking about pointers, which could be used in the interview situation, where I can bring cache. So like I told, like, okay, before fixing single point of failure, can I bring cache? Okay, now cache is not helping me. Then I can split, because already I'm microservices world. So I can have different data store for different services. So these are the things which we can bring in.
Yeah. What about consistency of the database as well?
Yes. So that is a good point, which always where things get struggled. So like now I told, like search is in Elasticsearch. So this is my Elasticsearch thing, but this should be consistent with the actual database. So these all things should be taken care when you are splitting your data. If you have data duplication, I will say inconsistency will always be there, but we have to take that but again, in distributed systems, there is one thing which you always take into picture: 80-20 rule. If if 20% of my data is serving my 80% of traffic, and if I fix that first, most of the things will work really good for me. I generally use this 80-20 rule. Does that make sense?
Yeah.
Yep.
So basically what I was trying to say, like, okay, there could be inconsistencies, but that 20% of data which serves most of my 80% traffic, if that is good, if I first fix that, so that means my user customer experience will be in a good state. Like I mentioned, this could be a retail site, and mostly people search for beauty products. Let's say it's really popular in females, and they search for beauty products. So if my beauty products data is always in good state, that means most of my traffic is like going for the beauty data. It could be like some other product which is rarely used, could not, if that is in, that again should not be inconsistent, but still, if I want to compromise somewhere, that is I'm just trying to add. And that works in different scenarios also. In the caching also it works, like what kind of things I should cache. But I don't have a very good answer for inconsistency, because I've seen distributed systems struggle with inconsistency of data, because when you split your data in different data stores, there would be some latency or somewhere some errors because of that the data could go inconsistent in different stores.
Yeah, one of the main important issue that I can bring up is like if you split database into multiple, like if you have to make update in multiple databases, like through multiple services, like one of them succeeded and the other one failed, or like one of the updates successful and the other one is not, you'll have to use some patterns, like I don't know, I think there is a saga pattern, or there is one other pattern like which takes a distributed transaction concept to overcome this. I mean, like to be in sync. Like one of the database could fail, but like the other one could be up. There are many scenarios which could come up once we split the data. So
yes.
Again, it depends on the use case, right? Because we know that we are dealing with the
yes.
distributed systems, that they are
Yes.
prone to fail, and
Yes.
we need to apply the cap theorem and see what is more important for us. And based on that, we can decide on what type of databases should we go. Definitely for distributed databases or distributed cache, there is some lag, or definitely there will be some inconsistency. But that again, it depends on use cases that we need to decide. So if this is the case that was discussed in interview, we can ask the interviewer to tell us what is more important. Is it the consistency, or is it availability, or is it the partition tolerance? And based on that, we can fine tune the solution.
Yeah, I think Aditya, the issue that I was planning to tell was you have consistent databases. All are like let's take like all of them are RDBMS, which are adhering to asset properties. But there is some transaction kind of capability in your system, some feature which requires you to update in multiple databases, which are covered by different microservices here in this example. So if your transaction is spanning multiple, and after updating one of them and it failed, like one of the other server crashed, or like it is down, or whatever it is, like there you have some inconsistency in terms of data, like when one place it is updated, the other place it is not. So to get around that, like there are some patterns in microservices, and one of them revolves around using the distributed transaction concept, I think.
Okay.
I have a question about the 80 and 20% rule. Is that a static, or it can dynamically set on the fly? I mean, 20%
that is, I think, a discretion at the developer level, or like how they target things. It is not like I think something. I don't think that it is something I can code myself. It is just a discretion which I can take as a developer. Hey, this kind of data catalog is being used a lot. That should be in my cache.
Okay, so it's static, cannot be dynamic.
It could be dynamic based on things, but I don't know how to make it dynamic. It could.
Yeah, cache. Whenever you are choosing cache, you have to choose your strategy, right? Like LRU, like whether you want to keep list recently in the cache, or like there should be a mechanism for items to go out of the cache and to enter cache. Whereas like one of the scenario is like if there is a cache miss, like some read query didn't succeed, then once it reads from database, it puts in cache. So the subsequent reads will get out, will be read from cache. And one of the, if the cache is full, so if we use LRU, the last one which was not used, like in the doubly linked list, will go out of the cache, and yeah, some other item will come to the front.
Yes,
So
different
some
strategies.
strategies, yeah, depends on the strategy.
Like what kind of things I want to bring. But what I was trying to say was earlier that if I have to, like, say there is some data inconsistency in two different systems, and if I have to sync it myself, so first I'll go for that records which are most critical for my system. And then I will keep on fixing everything if something goes wrong. That was what I was trying to say. Okay, we will proceed for. So basically, we have covered. So I was thinking of having a better example of splitting database, but again, if your data is shared, try to have one single first database and then only start splitting where it is needed. That's what is my take on that. So we also discussed about cap. So basically these all things will come into picture: consistency, availability, partition, tolerance, as we are creating the system. So I think that was all in my mind for the microservices. Anybody else want to add something? Feel free to chime in.
Could you talk about the deployment? How would we deploy and when the service is still running, right? We don't want to like stop the service and deploy it.
Mm-hmm. Oh yeah, so that is a good question. So now let me rub this thing, and so that is a different deployment strategies which we can do. Is so for example, this is my service right now which is running in infrastructure, and when I have to deploy, there are different things which I can do. Is there is always I forget its name. Let me quickly check. So that was it used to call this
Jenkins.
No, not Jenkins. That is called that is sorry, I split from my mind. It is actually like a rolling. Oh yeah, it is called rolling deployment. So basically, I know like I have a few instances. So first I'll bring one instance down and add a new service thing, and then keep on doing. I will kill all of them and deploy everything. That is called a rolling deployment. It again depends on us how we want to do. I can say like, okay, for few seconds, for few minutes, my service will be down. I will deploy everything and will make a service. Or I can do a rolling deployment. I can take one container out, put a new one, and then keep on putting everything. Yes, so that is one thing which, and these all things comes really handy with these kind of infrastructure like Fargate, ECS, Kubernetes. That is not something I have to do. I have to just tell, like, whenever I'll do deployment, it will be a rolling deployment.
Do they handle the schema changes?
Schema changes of.
So in the rolling deployment, suppose I have V1 of my service running, and in V2 I have got a schema change. So some existing things have changed. So because it is a rolling deployment, I assume some clients are already using my old client, which do not have the new schema. And now for the time of the deployment, when the deployment is going on, there are few computers which are running the old code and few which are already running the new code. Now, because the service is stateless, if a client was talking to a new what should I say, new endpoint which is running the new code, and it gets routed to the old code, now obviously it will be broken because the schema has changed. So do they take care of those type of things? And
so you mean like a contract has been changed?
Yeah, contract has changed. Yes.
Yeah, that is a good point. So there are different, again, as a developer, we can take that decision. Like if I have to do, I can say like, okay, this was my V1. And now if there is a really big change, now I am introducing a V2 of this. Or what I'm doing is like a backward compatible, either way. So I have to also think in that way, like, so if it is altogether new functionality, I would like to put a V2 version out and then slowly ask my customers to migrate to my V2. But if I'm just doing some bug fixes and other things, I think that can go as a rolling deployment. And that is a good point. I want to come to V1 and V2 also. So yes.
So to add on to that, right, that particular decision relies on the developer and not on the deployment front. So for rolling deployment, what they care is they just care about, if I'm correct, they care about the traffic split. They gradually increase the traffic in some of the data centers, and then they do next set of deployments, and then they increase more traffic. I'm not sure if V1, V2 can be handled through the what we call it as green CI or a green deployment.
Blue-green deployment.
Yeah, but it's essentially, I believe that it's something which the application owner or the developer should take a call on that.
So there are a couple of things. Let's say I have to altogether change the contract. So a lot of changes has happened. A new modern next generation version I have launched. So it can go as a separate V2. And I can say like all my clients, okay, now you have to switch to V2 and slowly. Or it could be like, we have not changed so many things, but still it could be a rolling or a blue-green deployment. If people are not aware about a blue-green deployment, so technically what I'm doing is I'm putting one more V1 version out. And this is my load balancer. And I started telling, okay, send 20% of traffic here to this cluster and send revenge. So basically it's like first I will put my new changes, make sure like new changes are good, and then switch this cluster to this cluster. It's something like that. I have not also used it fully, but because this blue-green deployment thing came into discussion, that's why I thought to share with you. But I would not like to go that much in detail, but in general scenario, what we generally are doing is adding new endpoints, new functionality, or bug fixing. Then a rolling deployment can be a good candidate. That's what is my take on that.
Okay, thank you.
So you have existing microservice, and now you have the new microservice. It exposes new API, right? So how are the existing microservice know that there's a new API available on this one? Because they're still using the old code.
So basically, they have to update their endpoint if they want to call my new API. That's sort of like my understanding. So I will say, okay, this new V1, V2 is available. Anybody who wants to call, update their configurations and start calling this guy.
So kind of like discover there's a new API, new.
Or update your Route 53 to send traffic to V2 version. It could be different things like the developer level, which I would take. But there's another one thing which was coming to my mind was, which is really important, which I have missed initially. Now I have this V1 and V2 versions are going on. And tomorrow I will also put V3 version out, let's say. How I will know who is using my V1, V2, V3? And when should I shut down my V1? That is another, I think, system design interview question.
Back from the load balancer, right?
Aseem, can you repeat the question again for a sec?
So what I'm telling, I put V1 version out, V2 and V3. Now I have a lot of versions out. How I'll know when I want to kill V1 version? And because if I'm running a V1 version, V2, V3, it is costing me money. So how I'll know, like, when I have to bring down things and when I should fully move? Anybody want to take a shot on that?
So typically how we are doing in our current work is we have V1, V2 and V3 coincidentally. So we are giving some end of life for that particular V1 version of REST endpoint, and we are saying that by end of December 2020, we are going to retire it. So we are giving some time for our customers to integrate or upgrade the endpoints, and that is being communicated like way advanced, at least one year in advance. So that's how we are currently managing, but I'm also interested to know if we can do it much better.
So yeah, so somebody is in Africa is using your service and you don't know, or might be your service is used by a TV, like and we don't know who is using, and then how I take my decisions. That is a question. And so even I don't have very clear-cut answer, but now this comes into picture, which is really important in any distributed system, which is monitoring, telemetry, and alarms.
Yeah, correct.
So if these things are not there, whatever we did till now will not help us. If these things are not in place properly, whatever design we made at the end, it will fail, because if we don't know who is using it, what is my monitoring thing, when somebody is going down, would it alarm me or not? So that things are important. So basically, every aspect has it should have a monitoring thing, like who is, how many requests we are coming, how many 200s are coming, how many 400s are there, 500s are there, and like these all things are really important for my monitoring, logging in, like how many requests are coming, and using that I can track, and then I can have alarms on top of it, like, okay, if 500s are more, it should alarm the on call. Without this, I can't take my decisions in the future. So again, coming back to that, if I have a proper V1 thing, then gradually I will know nobody's using my service, and it's time to shut down. If in last 6 months there's no request came, so that means that is as much as obsolete now. Like again, that decision the dev team has to take. But if I don't have enough data points to take a decision, then it won't happen. So that's what I was trying to bring.
Yeah, that's really a good point, because telemetry is really important, and we do have some we can directly use some of the solutions in market, right? We have New Relic, which is highly being used, and for Amazon itself, they do provide lot many monitoring services. But what I have seen is New Relic is being very popularly used, and for Java, we already have JMX that gets exposed. One more is Log2j or Log4j, something like that. Yeah, Datadog is also a very popular one.
So basically what we are trying to discuss here is like all your services. So these are the tools. If I have to do telemetry myself, that would be like something I would be doing. I end up writing my own solution, but there are out of box solutions, which comes like New Relic, Datadog, in AWS, this CloudWatch, logs and other things which I can use myself. So basically, generally what happens, like we discussed about that container where my service is hosted, basically it will also have some kind of an agent which will keep on taking my logs and will keep on pushing to either Datadog. It will keep on taking down different aspects of my CPU, other things or logs, and I can just publish them there. Or yes, so even we can use something like Splunk to put all our logs from the service to the cloud. So these are all things we have to take, and then we can create dashboards using this data and decide what kind of decisions which we want to take.
What was the third point after telemetry?
Alarms. Alarms are really important. If in this modern day, on-call is something which every dev team follows. But how on-call would know something is going wrong if I have put correct right kind of alarms, like if my, let's say if my 500 requests are going really high, or so that means it should trigger someone to take an investigation. But how that 500 thing will record if I have some kind of a tool or agents which keep on recording that data, and then I have a ability to create a threshold that if 500 requests are coming so high, then it should trigger a alarm. And other things which are which people will talk in system design interviews is your P99, P90, P95, P90. So like what kind of model you're supporting, P99, P95, P90. Based on that also we can create alarms. So now my service is out. How I should know whether it is behaving properly? Is it meeting my expectations or not? These all data would tell me, and if it is not, then it should create an alarm. Or it should be these days. There's a new, not these days. There's another concept called self-healing. If your application is self-healing, like nobody should manually intervene it. It should heal itself.
See, like we break it down to multiple microservices, and each of them run in its own container.
Mm-hmm.
And let's say if I have bug on my in one of my requests,
Mm-hmm.
I need to obtain a global log,
Mm-hmm.
right? How do I look at how do we generate that log?
Global log, sorry.
Log for to trace where to see because let's say if I have monolithic, I only need to look at the log, the application log, and I know exactly where thing is, right? But now there's multiple container,
so but
and things can happen here and there. How I look for the information?
Also it could be a container, but there is another concept called tags. You can tag your container with some tagging thing, and based on that you can say, oh, all my order service should have all these tags. You can go to there are tools like Splunk which will tell you, okay, where you can say, okay, for tag order service, give me all the errors which happened in last 15 minutes.
And to add on to that, like logging whatever we do from the application point of view, it should be comprehensive. It should tell what machine it is, what is the container it's running,
Yes.
what request it got. So it's the responsibility of the developer to log it, and because these are distributed systems and they are prone to fail, so we should take more responsibility on our side and provide the proper logging mechanism.
Yes, but logging only log at one container, right? Happen can, while I want to look at the full picture, when the request go, end up this container, the other container, going from A to Z and see where it fell, right? But if I look at one container, it's not enough information.
Okay, can I come in for, so can I come in quick for this log thing?
Sure.
So the point you are raising is very correct. The first thing is that in distributed system, logs are also distributed in a sense. All the logs goes to one place. Okay. Now having said that, I can still look at the individual log, but the very good point that is coming is basically request start at service 1, right? And then it goes through my system from 10 different containers. So I should have something to correlate that request from one to another. And most of the time it can be used, there's a different term in different system, but it will be used using the very simple term is a correlation ID. So when end user generating a request, suppose for API, the UI generate one single entity, either it can be GUID or something else, a correlation ID, that they pass to the API, right?
Yeah.
Now API carry that throughout the system. So the first entry point, use that and include that in the log. Now that calls the downstream other service, it includes that as well. Now you can have a different design basically. The first one, basically calls with the different correlation ID to the downstream. It doesn't matter, but as long as we can make that linking, that chaining, and we can obtain the whole log going out of a different container, we are good with that.
So basically, generally we have, so this is again as a developer, how we are doing things. And so basically there are, and if I'm logging with this correlation ID, which is used for one single transaction across different components and services, and then these kind of tools like Elasticsearch and other things or Splunk, they are really good in telling, okay, for all unique correlation IDs, where all components it hit, which component it got error. They're really good in kind of doing multi-dimensional, showing you a multi-dimensional picture.
Yeah,
we can do a lot of data slicing with what are the data they're collected by these agents, especially from Splunk and Neuralink. They do really well, and they've been proven to be working in the distributed area.
Yes, but if I don't have enough logs or information, I can't take decisions. So again, coming back to that one where I have version 1, V2, V3, but if I don't know who is using it and what kind of requests I'm getting, whether it's 200s or what is my latency rate, I can't make new application features or think in that way. You already have application which is serving your request. You have your P99 sets, but now you did a new deployment. It should be better than the previous one. It should not become the latency and error. It should not increase after that. It could be a snapshot between what was previous and what is current. And if it is the current is bad, it's better to roll back.
I have a question. So I'm in the test development. So how do you do the triaging? So if you get a bug and then it is similar to what correlational IDs you're saying, and do you guys go on the Splunk or that log monitoring system and take it, or you just go, what files to look at and then just to grape and things?
See, if I have to do, I would expect there should be enough logs in the some logging system like Splunk. So I should start looking into that. Without that, it's really difficult because in the distributed systems, you don't know where the request, from where it originated, where it went, where it got error, and other things become really, really tricky if there are not enough logs. And generally, it is encouraged to write enough logs as part of your application. Like that should be as part of your code review, where you tell other developers, have you put enough logs? And okay, and also don't overflow the logs, because sometimes people start logging everything and it will bring down the Splunk cluster. So we have to be really mindful what we want to log. It could be debug logs, warning logs, info logs, error logs, and we have to be mindful. But at least for our error logs, it should have enough information like let's say assume like there is a correlation ID, but the developer forget to add a correlation ID in the log, then it's gone. I couldn't find it now. If I go in the logs also, I can't see like if this component has used it or not.
Also, correlation have to base on some sort of like global time, right? Because each container could run on different computer and they don't share the same clock.
No, correlation ID is not based on the clock.
But look at the log. I want to see what statement, you know, execute first and what next, right? But if it reverse, then it's impossible to detect, you know, what happened, what wrong.
So generally, I think all these logging things could also have a UTC time when the actual logging system got that information. Based on that, if it is Splunk, it will also have like when Splunk got that information.
That may not, I don't see how it works, because, you know, that service happened on this server right here, another one happened different server, but then when it comes to Splunk server, the timestamp could be different. Then, you know, one service, you know, really, you know, happened first, but it arrive to Splunk server later, then it logged it, you know, later time.
What is telling, like Splunk will also register when that got that information.
So time is registered at the local when you log it, not when it's sync. So sync can happen after 5 minutes or 10 minutes. But having said that, there might be a little bit delay here and there. Basically, all the good logging system, you know, have a epoch in their one of the column in the log, and but still you can figure out basically who calls who based on your understanding of code.
Okay, I think that's all from my side. That's all things I want to cover. So if you have any questions, we can hang around. Otherwise, we can. I was thinking to cover something around asynchronous processing using queues, but we can do it next week.
Yeah, I have a question. Yeah. Can you give me some example of telemetry?
Yeah, but let me, Bhavish, shall I stop the recording?
Yes, let's go ahead. I'm actually co-host. I joined a little late, so I can't either AP can or someone else.
Stopping the recording.